and welcome to another episode of FooBar. In today's episode, we are talking about Terraform on serverless. If you want to know more about serverless, cloud computing, or software engineer practices in general, subscribe to my channel in the red button below. I post videos on Tuesdays and on Thursdays, so let's get started! This is another episode in my series, This is Not a Podcast, and today I'm talking with Anton. Anton is an AWS hero and he's also a Terraform expert. He will be telling us everything we need to know in order to get started with Terraform and serverless. So let's go to the interview. Welcome, Anton. How are you doing?
Hello, I'm doing fine. Looking forward to share my knowledge and my passion, I would say, with your audience, which is growing. That's good.
It is. And I think I never spoke about Terraform because it's something I never tried. I have a little knowledge about it. So today we are going to start from the basics because I always use these interviews to learn a lot of things myself. It's a very selfish way.
That's the right way.
Yeah, and I think you're the perfect person for that because you are a fanatic of Terraform. So.
Yeah, that's really what I've been doing for many years. And let's...
Tell us a little bit about yourself and what you're up to, and because you're very active, at least in the Nordics.
Yeah, sure. I'm AWS Community Hero as well as HashiCorp Ambassador. And I try to stay pretty active with a bunch of different Terraform-related activities. So for the last several years, I've been contributing and maintaining a lot of Terraform AWS modules. And I speak at many conferences because I want people to know how to use Terraform with AWS in a more efficient way. What are challenges if they use specific features. And in general, I like to be active in the community from different angles. So what we're going to talk today is one of my recent passion. Serverless is there, and I'm glad to share how it can be done with Terraform.
Yeah, I think this is a little different way that you see in most of the places because everybody talks about serverless with Amplify, with SAP, with CloudFormation, with serverless framework. And this is at least very new for me on how to do serverless with Terraform. So I'm super excited of having this chat with you today. But I think the first question we need to ask is, what is Terraform and why we should use Terraform?
Yeah, that's definitely the basic question, which I will be glad to answer. So first of all, Terraform has started as a tool which allows to describe and create and manage infrastructure as code. It started after an inspiration from CloudFormation. While CloudFormation is a tool by AWS, which allows to manage mostly AWS resources, Terraform has started as a tool which is provider agnostic, and you can use the same code to manage resources across multiple providers in multiple public clouds.
The same code?
Well, the same syntax. Okay. The syntax is the same, but code which actually provision these resources is different.
Okay, because it would be very magical if you can do exactly the same code.
Yeah, that was my first impression myself. When I started working with Terraform back in 2015, I thought like, wow, I can manage everything with few lines of code. And then pretty instantly I figure out that, well, no, that's not possible.
No. Because every cloud is very different and they have different ways of doing things.
Yeah, and I'm glad that Terraform does not provide us a lot of magic. It's quite easy to understand what's going on, how to modularize your configuration, how to extend it, or how to put it even into pipeline.
Okay. So is Terraform closer to CloudFormation or CDK, where it stands?
Well, I would say that Terraform started as a next step for people who couldn't do something with CloudFormation. And Terraform had built-in concept of modules and reusable components, which are essential part of CDK.
Yeah.
CDK has constructs, and CDK is friendly for developers.
You say CloudFormation is not friendly.
Well, if you're a big fan of JSON and YAML and don't mind to copy-paste a lot of code, well, yeah, then CloudFormation should be used immediately.
I love CloudFormation, so.
Yeah.
So basically, the main benefit maybe of choosing Terraform is that you don't need to learn something else. You can move into different clouds. But what if you are using only AWS? Because in general, most of the customers are using one cloud provider. It's not a common thing to have multiple cloud providers. So why still Terraform?
Yeah, that's really a good question. Sometimes I have hard time explaining this because people say like, hey, CloudFormation is supported by this cloud provider, and there is something else which potentially is worse than CloudFormation. So my answer usually is inside of what do you want to do? CloudFormation has never had concept of modules. Well, you have stacks, you have nested stacks, you can combine them somehow, but there is no possibility to get existing code and just reuse it or extend it in some way. So that's what I've been working for many years in Terraform AWS modules, where me and a few other people, we have developed modules for everyone else to spin up reusable infrastructure components like VPC or security group or anything else.
Yeah, that's really good to point out, because in general, when people think about, without knowing much about any of these solutions, they think, oh, if I need multi-cloud, I will go with Terraform. But if not, if I need to learn something from scratch, I might go with CloudFormation. But there are other reasons as well, and I think this is really good to mention, because it's not as simple as it looks.
I also think that the biggest benefit in at least 2020 is that people should be able to use tools without learning them in details. Like when I work with CloudFormation myself, I've been doing this before I switched to Terraform completely. I had a lot of challenges to figure out what exactly to put. Like, okay, I want to create this resource, but what exactly to put into all of these values?
Yeah. I think CloudFormation has a very steep learning curve, and that's what I like a lot of these serverless frameworks like SAM or serverless framework, that they start with a set of kind of simple constructs for things that are used a lot, like functions and API gateways and things like that. And then when you need to start adding things, you can start learning gradually CloudFormation. At least that's how I learn it, starting always from a framework, and then, okay, now I need to write a dynamo table. How I do that with CloudFormation? And now I need to make a queue. Oh, and I need to connect this to an existing S3 bucket. And then you start learning all these pieces on how to do it little by little. But it's true, it's a hard learning curve.
Yeah, and I also think that if you have been using any of these tools, you already figure out your ways around your hacks. Like if you will be given task like, hey, can you please create S3 bucket? You will not probably write it from scratch. You will take it from another project where you use it, copy paste it. I mean, that's how we work. So Stack Overflow driven development is really, really important. Just the most important part is to know from which part to copy code, from question or from answer.
Yeah, I always laugh because I have this GitHub repo where I put all my demos for my YouTube channel. I think I'm the most active users of my own demos, because I know I wrote that code, I investigated how to make it, and then whenever I need it, I just go copy paste my own code. I know it works. It's kind of, the research is done. I just can't go there. So it's a very selfish way of having all my code available for me.
Absolutely same about me with Terraform AWS modules. I know them by heart, and I simply search there and find specific piece of code. And people sometimes ask me like, "Hey, how do I know that this is the parameter which you need to pass?" Well, if you write on this, then you know. But if you have never written them, then Terraform has a registry, which is a hosted website where everyone can list their pieces of code.
Okay.
Something like
NPM?
No. Yeah, like NPM, but what is it? Serverless
application repository?
Repository, yeah. Something like that.
Nice.
So people can go there, search by name.
And find the modules.
Yeah, find the modules and at least figure out how to use it and maybe develop it further for their needs. But at least it's a good starting point.
That's really cool. And when you get the modules, are the modules like open source that you can go and check what is inside there?
Yeah, if you manage to find them, then they are open source.
If not, then they can go to your website and find all the AWS modules because you have them.
Yeah, but approximately 90% of modules which I write are open source.
That's good.
And I share them quite happily with all other people.
Yeah, that's quite important because if it's not written, well, in the case of AWS, CloudFormation is written by AWS, so you're trusting the whole platform. But when you're like open source is good for opening the trust with the community and what developers are doing if you want to share important pieces of code. Yeah, and I think at the end of the day, at least my opinion is that you always need to have infrastructure as code. It doesn't matter if it's Terraform, CloudFormation, CDK, or whatever you like, but have at least something that you can put your infrastructure into code. Because if not, you will regret it very, very much in a couple of months.
Talking about infrastructure as code, I wouldn't actually call it as code. I mean, Terraform at the end of the day is configuration.
Yeah.
So, infrastructure as configuration files, that's but infrastructure as code is more like CDK approach.
CDK. Yeah. Well, I call it as code in the sense of the benefits that you can put it in the repository where your code is. You can deploy it all together. You can track the changes in that way. But it's configuration or whatever. But that is in a script, and you don't go to the console and click. That is, I always very crazy when somebody's learning something and they just start from the console. I know sometimes it's the easiest way, but it's a very dangerous path because then you get used to doing things on the console. And then when moving to whatever is your preferred tool of infrastructure as code, as configuration, as you call it, then it's a very hard step because you are used to doing it. So for me, it's like always trying to learn from the code or the scripting first, because then you don't need to do that jump. And even if it's a little harder at the beginning, it's I think best result at the end.
Yeah.
So let's talk a little bit about why serverless with Terraform. Why it's really good for serverless applications and what it takes good from other frameworks and does it better.
Yeah, that's really a big topic, and I will be really glad to express my experience in this area. Well, let's start with, again, like a summary of what Terraform is good at. Terraform is good in relations. So Terraform is good in generating dependency graph and trying to make changes to the infrastructure to feed this dependency graph. So once you specify something in the code, it will be job of Terraform to figure out what resources will have to be updated, created, deleted, and in which order. And when we are talking about a serverless application, at least when I've heard about it for the first time, it was at reInvent, I think 2014 or 15.
Yeah, 14 they launched it, so that's
I was like, wow, that's so good. I'm a lazy person. I really dislike to log into EC2 instances and do something there. And I can actually focus on just my code, which in that time was primarily PHP, but also part of Python. So I thought, like, yeah, that's exactly what I want. And then I figure out over time that, well, serverless on keynotes looks easy, looks good, looks like, wow, that's awesome. But when you're actually trying to use it, then, oh my God, that's totally different type of scenario. So then I started to figure out that, okay, we have serverless as a concept, which I love. I always love it. And then we have tooling, and then we have infrastructure, and then we have application deployment. And now we have all of these tools somehow connected, somehow scripted. And I was like, wow, that's not a good fit, because I want to have simplicity, because I was promised it by Werner Vogel from the stage. So give me simplicity, and don't try to convince me that this simplicity is good. But you also need to do something in CloudFormation or other tool or other frameworks. And after a few years of using Terraform, I discovered that there are no open source solutions where people actually try to work with serverless infrastructure and as well as applications with Terraform. And when I ask why, I was like, well, but this is hard. Yeah, but this is hard, but why? So then I look into what are the basic concepts of it. And the basic concept is that code, dependencies, well, dependency means Terraform. Code means Python code, which that's it.
Yeah.
So I really like to use Terraform for serverless, simply because it handles dependencies much better than anything else.
Yeah, I think it's one of the challenges of how to build these distributed systems, that you have so many moving parts and Legos, like using so many managed services, and how you construct that. That's hard, at least with CloudFormation, and how to provision all that, and how you build this kind of architecture. So I'm really excited to see how Terraform solves this. And you have done some work that you want to show us, this Serverless.tf. What is that?
Well, Serverless.tf is, as I like to talk about it, is a opinionated framework which contains documentation, Terraform modules for many of AWS services which usually used in serverless applications, as well as playground project where I'm actually showing how these things are implemented together.
So it's not only like Terraform modules, but it's a framework itself. So it has a lot of things.
I checked definition for word framework, and it seems good.
Good.
it seems like what I want to be doing, because framework consists of reasoning why this exists, what kind of problems it solves, and also giving possibilities and building blocks to build these solutions. So
what is the main problem it solves then?
Well, there are good parts in existing solutions and also challenges or bad parts. It depends how you call them. So the
challenges sounds nicer.
Yeah, challenges, because absolutely, for many people, they are not bad. And people get used to it. I mean, thousands of people use existing solutions. And if you talk to them, they're happier. That's great. So definitely, everything what I'm going to show is just my opinion, my experience. Yeah. And absolutely, I'm not representing anyone else.
And that's the nice thing of having a broad selection of options. And that's what sometimes people ask me, what is better? What is like which things to choose? And it's like, you need to have a context. Without a context on what is the problem and what is the whole things around it, it's very hard to decide which framework is better or which tool is better than others, because they all have goods and bads. So you cannot say always use this framework over others, because this is the right solution. And I'm thinking technology is picking the right thing for the right moment.
Yeah. Well, I'd like to explain or highlight really good parts of existing solution first.
Yes,
because
please.
existing solutions are are there lots of people using them with various success, but I believe that they're good. So my personal experience has been based on serverless framework, which I used for more than 2 years, actually 2 years now. I have a few small projects, not huge projects, but small. And I also have been working as a consultant on a project where they use serverless framework on pretty big infrastructure. It's like 60 or 80 different functions with a bunch of different services connected. So I can see this myself. I was not writing any solution for them, but I just experienced from outside that, oh my God, something is going to explode. Well, and also I have been looking into Zappa. Zappa, well, it was about 2018, I guess, and it was pretty good solution back then. The only problem is that I couldn't get it up and running during 2 hours.
Oh.
Yeah, but then when I hard coded and fixed something, I managed to get it up and running. But anyway, it was not a pleasant experience overall. But I know a few people who are happy with it. So that's it. And my recent experience was with AWS Chalice, which is a pretty good framework, but not in the sense of serverless framework, because serverless framework is big. But AWS Chalice is really small.
Yeah, it is.
And in my company, which is Better Job, we are actually looking into how to use bits of AWS Chalice libraries in our tasks. So the good part is
what is that? What is so interesting?
Yeah, I think the good part of Chalice is that it's written in Python, and developers already thought about how to handle response and request objects.
Okay.
So we want to just include those classes or functions inside of our Lambda functions, and don't care about how to wrap response, because it's going to be returned for ALB.
Yeah.
Because ALB and the API gateway, they expect different type of response.
They do.
And I don't want to think about this inside of my Lambda function. I want to use AWS Chalice, and hopefully they implement it themselves and correctly. And again, I don't like to write code which doesn't give any value for me.
Yeah.
And they did it quite nicely, and that's what we use.
That's really good. I need to check Chalice, but as I'm not a Python developer, I never got around it.
Yeah, and that's actually another story, is that I am much more Python-related person than Node.js and TypeScript. Every time when I have to deal with plugins in serverless framework which are written in Node.js, I'm really disappointed. The reason is that it's not just because I don't like the language, but it's just something what will take me further from writing my code. Because remember, that Werner promised us that we write only code.
Yeah.
And this code should be in my favorite language, not in the language of the framework. So
that's a good point. I think for writing that type of things, because it's something never occurs to me. I'm so used to being in the Node world that everything is just package your application, npm package.
And that's quite funny that on our one of the recent discussion we had with the AWS heroes, where someone asked, what is the programming language you want to use, or do you use with Lambdas? Like 80% of people said Python.
Oh,
yes.
That's interesting.
So probably there are some signals that not everyone is a big fan of Node.js.
Yeah, exactly. And as you said, why to mix everything if you can? If you are using one language, it's kind of awkward to mix kind of things.
But actually, one of the next thing which was good with all of these frameworks, with minor exceptions, as I mentioned earlier, is that it was really easy to get started. Well, especially with serverless framework, you just go to documentation, you see hello world, you fork the example, or you write SLS, create project, and you have it, and that's pretty much all what you need. The only problem with all of solutions and hello world example is that your business is not hello world.
Oh no.
And again, being inspired with serverless and using serverless framework is always two different things. It's easy to get
started.
I
think that's one of the biggest challenges with serverless, because you can sell it so easy by saying, hey, hello world. But then when it comes to a real application, it's not just knowing how to code and the technology, but you need to change the way your brain is hooked to build these kind of applications in a way that makes sense. And I think that's the kind of biggest jump from, if you are doing like traditional applications, it doesn't matter if they're in virtualized servers or containers or whatever, you do them in the same way. But when you jump to the serverless world, it's just like, if you don't change the way that you're thinking and you're developing your applications, you will suffer a lot.
Yeah, exactly. And I'm really surprised that almost no frameworks are showing the truth instantly. Like when you start using it, I would really prefer that most of tools show that, hey, this is hello world example, but if you keep doing the same things for like 1 month, you will end up with this, and then show the real project where it's pretty much hard to understand what's going on, how things are flowing between.
I think there is also the thing that serverless is so new that it's not that, well, I don't think it's a framework fault that they are not showing what it will happen, because everybody will do it in a different way. But it also happens that people like me or you or whoever, like all these influencers of the serverless world, we are learning and we are seeing the things and we are learning the best practices. So I think there's still a lot of step to learn and to be able to share. Like, I think now we are getting better, but at least when I started in 2016, there was nothing. Like, you could, nobody knew how this thing will behave in production. And actually, when it started, it changed so much than what is today, what you could do, and where were the limitations. That I think it's a hard thing. But developing traditional applications, it's been there since, I don't know, maybe 20 years. We have been doing applications in a similar way. So I think there is way more books and stories written about it. So I think for serverless, it's a matter of time, and definitely we need to tell the story and tell this is the path to learn, and this is the change that you need to do in your brain in order to produce serverless applications that are maintainable, that will not drive you mad in the next 6 months.
Yeah, that's really the case, that most things which we have right now are very new. So when I was working with, when I started working with Terraform and start attending different conferences, I've been asked so many times, so repetitive questions, like what is best practice of doing this and this, and how do you structure your code? Well, I took my time and I just summarized what I thought, what I practiced, and what I see in wild, and published TerraFormBestPractices.com. Just because there were no best practices, so I decided, well, if there are no best practices, then my practices will be best practices.
Yeah, but that's the way you start. Somebody needs to start the discussion, and I think at least the serverless community is a very verbose community. If you follow the hashtag serverless in Twitter, you will find a lot of stories and people having discussions over and over again, and I think that's how it should go, because until we don't build a bigger common knowledge on how things should be done, it's very hard to have best practices. And the persons that have the longest serverless experience might have 5 years working with serverless applications. Exactly. So it's very new.
Yeah, so we should probably see job offers where they request to have serverless experience with 10 years.
Yeah, I don't think that's there yet. I hope there are not.
Well, I saw AWS roles where AWS experience was required. I think it was about 10 years. So 10 years of AWS
Okay.
experience.
Well, AWS has been out for more than 10 years, so
Yeah,
you could
exactly.
ask for that, but
Yeah,
yeah,
you can ask.
I think the most senior people might be 10 years working in the cloud. Like it will be
Yeah.
very few candidates that can go there. But well. So,
Yes.
so now you have this idea to create this framework with Terraform and serverless, looking at the best things that other framework has, and also the challenges. What were the main challenges that this other framework had? That besides not showing you the truth of how it will be in 6 months, but I think that's not the framework work.
Well, yeah. Obviously, it was not problem with the framework itself. In general, with most of tooling which we have right now, which we've had for many years actually, is that once something failed, then the only thing which you see is either a stack trace, which, well, is not usually so helpful, or it says error, like error. Oh, thank you very much, error. Well, I guess that this is error. So what I was thinking is that when I was using serverless framework in particular, you have to run SLS deploy and you wait, and you wait, and then something happens. So it's like big bang release. Of course, I can release small functions and small updates in more controlled fashion, but I was always missing a lack of granular control. For example, by default, especially Hello World example, is just deploying everything in single AWS CloudFormation stack, and it's just growing. Organically, it will be just growing like until certain limit. And lack of this decomposition was like one of challenge which I experienced. For example, it took me a significant amount of time to figure out how to use Python requirements plugin in serverless framework to build dependency which I want in Docker with private access to private registry or private GitHub repository. And the solution which we can finally figure out was pretty impossible to explain to anyone else. It was like spaghetti code of YAML. There were includes, excludes, and good luck figure out who has presence. I still don't know, honestly, whether it's include or exclude, or when something was failing, you have to go to GitHub issues of the plugin itself and go there and try to figure out what's going on in that plugin. And we had challenges in several plugins as well. Like you have to be really experts in certain tooling in order to use it. For example, I never understood why you should put plugins in certain order inside of serverless YAML config. For me, this doesn't seem natural. I want system to figure out what is dependent on what and resolve it for. So that was also challenging. Well, of course, after a few months, we figure out how to use it and how to structure it. But when we look into expanding our expertise and start integrating AppSync into this project, it was quite obvious that our serverless configuration will explode very soon. So we could split it into multiple CloudFormation stacks. We could somehow orchestrate them, then multiply this CloudFormation stack on number of environments which we have. Well, it is possible, but again, I don't want to do something what is not related to my business.
Yeah, and I think that's super true, because when you are building your serverless applications that you want to have like a big application, then you end up thinking like, okay, I maybe need to start like 3 or 4 different, in this case, serverless framework projects, some projects, because then you will have everything in one stack, and then everything is kind of kind of together, what needs to be together. And then if you want to remove the stack or deploy it, then everything is kind of deployed together. So that's a very thing. And also, if you want just to deploy the code of a function, that's something I think sometimes with some is a little bit frustrating for me. Like, I don't want to regenerate the whole infrastructure. I just want to deploy the code, the line that I put console log. I want that. Can you do that in your framework?
Yeah, this was really the challenge with all of these tools. Like, I want to do just small change somewhere without frightened of redeploy something. Like, I know that this may sound like I am inexperienced, or I try to find nitty-picky things, which, hey, you just have to read documentation and figure out it. Well, but that's not the truth. I read pretty much all documentation of serverless framework, SAM, application model, CloudFormation, and many other things. But I still feel that challenges are are so big that you have to spend. So in your company, you have to find dedicated person who will now just stay like informed how to do things correctly. So he has to go to GitHub issues, talk to other people, read different blog posts, just to figure out how the tooling works. That's just not acceptable. In my company, we have one developer who is writing Python code, and really, I don't want him to switch to, hey, by the way, now please go and fix this Node.js, because plugins are there, and plugins supposed to be doing additional and like granular things, but tooling itself require us to know a little bit too much. So that's what started Serverless.tf. So just let me explain what is actually the last trigger why we say like, oh my god, no, we have to figure out better solution for that one. It was complexity of real deployment. That was like one thing. Plugin complexity was also questionable. Like, why do we need plugins in first place? Because I have Terraform where I describe all of this stuff already, and I have my code. What else do I need? Well, okay, you can say you need something to orchestrate and to deploy it, but deployment is rather similar to conversion from your Terraform configuration into real infrastructure. So making your real infrastructure to be exactly as you specified in the code. And that's job of Terraform. So for that, we were like thinking about alternative solution quite actively. And overall accidental complexity while doing serverless was rather exponential. Talking by numbers, when we started or when we were doing actually using serverless framework, we had to spend approximately 50% of time just struggling with tools, at least 50% of times. And again, we used these tools before. We just wanted to make it easier for us to understand. We don't want to copy-paste the first solution which we find on the internet and hope that next release doesn't break it. We want to understand what we are relying on. And when we figure out that, okay, we need to have something what produce Lambda function, what update Lambda function, then we figure out that, okay, serverless framework is not doing that, but plugins are doing that. Okay, so plugin is actually making or installing dependencies, making Docker images and so on. So that's why we looked into plugins as well.
Okay.
And Serverless.tf is opinionated open source framework, and I focus only on AWS right now, because that's what I work with pretty much full time.
Okay. Yeah, and one thing you mentioned as well, I don't know if you're covering it later, but you mentioned the capability of doing like testing locally. That's something also that it's kind of hard to do with serverless framework some or.
Yeah, testing locally is, I would say, is cool to have, but extremely hard to get it meaningful.
It is.
So you can think about it from another way. It's like, do you want to know that your application behave correctly? Probably yes. You want to do this as early as possible? Also true. So if you think about this as what do you need to know that your application behave correctly? Well, you need infrastructure, and you need application, and you need sequence of tests which you run. So application, infrastructure, and test, this is your code, Terraform, and your testing framework or testing tool set. So there are tools which can replace your infrastructure using, let's say, local stack, which allows you to spin up local copy or offline copy of your infrastructure. Well, it's
something sounds, at least when we were talking about this before, it sounds very interesting, because that's one of the main questions people ask when starting to serverless. Can I test locally? And it's like, yeah, I don't know, at least with the current tools, is but no.
I would say that you can do a large part of it like increasingly, from nothing to something, but not from nothing to absolutely 100% guarantee that everything works fine.
Yeah.
So there are some tools which can be used for that.
Like, and I think local stack might have the same problem that other libraries that are out there. They are just a copy of the APIs to mock whatever is happening. So if AWS tomorrow decides to update those APIs or change them somehow, it might work locally, but then when you put it to the cloud, and it might not work. So I think at the end of the day, the best thing you can do is always try integration tests. So it's kind of the safest way to make sure that everything is working as supposedly with the real cloud infrastructure.
Yeah, but I also think that if we focus on just like few things, that your application should have some infrastructure, and then you update, let's say, first you spin up your infrastructure locally, and you do some very easy tests, which may work, may not work, but at least you get an opinion that something is there. Then you can build your Lambda function, and you already described your infrastructure using local stack. You verified it, but then you just change your pointers of API custom endpoints inside of Terraform. So your Terraform provider will not go to internet, but will go to local stack, local endpoint, which is local host, and then some port. This means that you are now verifying your Terraform configuration, how they are going to be working inside of AWS. This gives you some understanding.
That's nice.
But then when you want to do real deployment, then you actually do it correctly on test environment, dev environment, stable, whatever you have. So this is like traditional pipeline.
Yeah. And we will look at how we will deploy this Serverless.tf in a moment. But
let's look into some slides which I have prepared. I didn't think about them like to be a really complete presentation, because I'm not sure that all of what I'm going to mention here is 100% correct. Well, you probably got it already. But still, the highlight of Serverless.tf approach is that there has to be much more decoupling. Building decoupling from packaging. Deploying is absolutely independent phase. You may deploy to development or staging environment automatically just by switching, by increasing new version, but not updating alias, for example. But your production environment is actually using alias and alias is deployed in conditional manner, and so on.
So if you're not using, this is a stupid question for somebody that never use CloudFormation. So when you deploy CloudFormation, you create this change set, and then you deploy the change set. With Terraform, you're not using CloudFormation. You're going directly to the AWS APIs. And what is the way that deploy? How you, for example, if you're using code pipeline, how you deploy? Like, this is a very stupid question, but I like those stupid questions.
Well, I also like these kind of questions, to be honest. I'm asking them daily. Yeah, so what you can do is that in Terraform, you describe what you want to have. If you want to have environment to be automatically deployed right now, for example, then you just specify this as a inside of the code where you say create deployment equal true. I will show this in a minute.
And where that code runs, do you need to have a server to run Terraform that is deploying?
Yeah, you should have some system where you run it. You can
like
run
Jenkins or Code Build or something like that.
Yeah, you definitely can run it from your local machine.
Now, we don't want to run for our local machine now because we are in an environment, we are in a production, going to production.
Okay. Oh, immediately to production. That's good.
Well, in a sense, we want to do it in the cloud or wherever is not our local machine, because I know in my local machine I can run it, but I was just wondering what kind of things I need to have in the cloud in order to be able to deploy a Terraform script or configuration into my cloud.
You need to have Terraform binary available on machine where you want it to be executed. So it's not hosted server for you. If you want to run it during code build step, you should install Terraform there, get your Terraform configuration, and then run Terraform apply inside of your code build step. This is very common procedure. A lot of people do this.
Good. So that's was my question. We can run it inside Code Build or inside Jenkins or inside any machine that we can install this Terraform and then apply the commands to deploy the script.
Yeah, I will show some other alternatives as well in a second.
Okay, I have another stupid question. Because you talk about build and package, so I imagine in some point you create the artifact. And is this the same artifact that will get then deployed into multiple stages?
That's the whole point, right? That you want to separate configuration from your artifact. So your artifact is built once, and it is only dependent on things which are critical for the artifact itself, like code itself or dependencies itself. So this means that once you build this artifact on your machine and then push it into central storage, then everyone else can use it.
Nice. And then they can enrich the artifact with different environmental variables, so they can deploy it into development. Okay, awesome.
And
that's asking all the stupid questions because I need
stuff can be done. Same stuff can be done for not just Lambda functions, but also for Lambda layers.
Yeah.
Which is Lambda layers are not big different from Lambda function itself.
No.
In terms of functionality, and that they can be built the same way.
Nice. Good.
So the core of Serverless.tf is Terraform AWS Lambda module, where all Lambda-related tasks are. Everything from building, artifact, packaging, and so on is part of that one. I wrote documentation about it, and I will show it in action soon. Once more, the focus is that I want everyone to write code the way they want, using tooling they want, without any external relations. So you use your favorite IDE to write your Python code. That's it. You do this in isolation, and using Terraform for absolutely everything else. That's main separation. The Terraform is very good in many of these tasks.
Okay.
And always put everything as code so that you can actually reproduce it as different environments, put it into pipeline, run different tests, run the same application on your local stack copy of this infrastructure just by changing custom endpoints API and paying $15 a month to local stack guys, because serverless servers are not free inside of local stack, which is pretty important. So if you are planning to spend less than $15 on your serverless bill for AWS, you can actually spin up real instances, real infrastructure, instead of running it locally.
Okay.
If you're only concerned in is cost. Okay, so if we look into what is the separation and what is actually the powerful components in the traditional or in established serverless solution, you have to use different plugins for that. For example, plugins or extension, it depends what kind of tool you're using, but AWS Lambda module has support for building and installing dependencies in countless different ways. So it can figure out from which source path to pick up source, which patterns to include or to exclude, and what kind of commands to run. And it will also be able to do exactly this, but inside of your Docker image if you want to build, let's say, dependencies which are going to be used inside of Lambda, which is not Macintosh. Well, Lambda is not running Macintosh.
Linux.
Yes, yeah. So and that's why you need to use Docker to build your dependencies. SAM is doing very similar things, but they also I can see SAM as moving one of the best projects in serverless ecosystem, which is moving in the right direction.
Oh, nice.
That's what I can say. I'm watching what's going on there quite closely, and I like what's going on. But
I've been using now SAM for everything, and I have seen a lot of evolution in the last 7-8 months. How SAM is going and the easiness that is in making the applications.
Yeah. Well, so this was about building and installing dependencies, which, as I said earlier, is absolutely decoupled from the rest. So if you want, you can use this Lambda module to produce this artifact as part of your CI pipeline. Or you can even produce this artifact on your local machine and store it on S3. And then all developers will be able to just point to that S3 without need to rebuild it, for example. So deployment package and creation of deployment package is optional as well.
Oh.
And the next step is deployment. Again, this is a very flexible way of doing it. By default, you can just specify that you want to publish new version, and AWS Lambda will increase version. This is fine for development and some other environments. But in real life, you would like to use something like AWS Code Deploy and do rolling or canary deployment or rollbacks.
Oh, that's available as well.
Yeah, all of this is supported, and it was very straightforward way to implement it. Again, because this is very much decoupled. So module which takes care of doing AWS Code deployment has nothing to do with what to deploy.
One question that I find it very annoying in the ways that are set up now, that when I have my Lambda function and I deploy it with SAM, I need to write in my SAM template that I'm going to use code deployed. And then in my dev, in my production, and in my staging, if I have a canary or a linear thing, it will take forever to deploy. Can I decide with this tool where to have my canary and in which environment not to have my canary?
Well, using Terraform, it's all up to you how you describe your infrastructure. So in demo, which I'm going to show, I put everything in one folder, so it's like one environment. But in real application, you would have several folders, one per each environment.
Okay, and then I could define different ways to deploy in each environment.
Yeah, exactly. Like in one environment, you can specify Lambda canary 10%, 5 minutes.
Yeah.
But in another environment, you can specify that all in one or all at once.
Yeah, because that's very annoying. For example, if you are deploying in development, testing, and production with Canary, it can or Linear. I don't remember which one. It can take like 1 hour to deploy your whole application. What is cool to do it in production because you want to shift the traffic slowly. But if you are doing for development, you just want your applications to just deployed and
Yeah, I was thinking about what kind of use cases can be implemented, and in most cases, I'm like every time when I'm thinking like, hey, this use case and this use case, what do they have in common? In most situations, it means that it's better to make them as decoupled as possible.
Yeah,
so
definitely.
you like literally one Lambda function or one project, let's say, which contains resources for one Lambda functions, consists of invocation of many small different modules. One module building something, one module updating alias, another module doing deployment, and so on. And it's up to you how you want to customize your environments.
Yeah.
So
and
yeah.
I think in a framework, at least my ideal framework is the one that I can do super simple things without, it's very opinionated, as you said at the beginning, about your framework. But I think I like that it has a lot of defaults that are very strong. But then when I want to do something that is very specific, I can also do that. Because when real life hits you, you don't want to have the same cookie cutter option that somebody else thought in a different country, in a different world. And I would like to have my very custom made, and there is where I like to tune the configuration files or the deployment scripts or things like that. So I think that the two sides are very good when you have a very opinionated thing that you can deploy super fast, and then when you have the options to do all the configuration, you
So. Yeah, but actually all of flags which are supported inside of control deployment, like, for example, rollback, enable or disable, in which condition, which CloudWatch logs metric to watch, and so on, all of this is customizable for you.
Nice.
But by default, it's set to disabled options unless you specify it.
Exactly. That's how it should be. And then if you can even fine tune it to which environment to turn it on and off, that I think is very powerful.
Yeah, I think deployment is really one of the most advanced feature which can be improved actually on all levels. Inside of SAM, it is also far from perfect.
Yeah.
And yeah, I think I started using AWS Code Deploy, I don't know, 2016 when it was announced. And I was really happy because it was like, wow, that's cool, because I was working with EC2 instances that time, and it was exactly what I need, so I can move my my other tooling, and now I can use the same tool, which I understand how it works, just by specifying different options to it, and now it does the same for Lambdas. Wow, that's great.
Yeah, and I think with co-deploy, you get for EC2s, containers, Lambdas, you get immutable deployments, and I think that's a very important thing in this world where everything can fail. That basically you can have a very fast rollback because the environment that you just deploy, it's in a new space, in a new, like, it's not overwriting whatever you have done. And I think that's one of the main benefits of using co-deploy, at least for Lambda. Even if you use the all at once, that you are not taking advantage of Linear or Canaries, that you are just deploying all at once. It preserves the previous version that you can roll back pretty fast if there is any problem. Or so I think it's a great tool.
Right now, I use all-in-one most of the time.
Yeah, exactly.
And we are experimenting with hooks before and after.
Yeah.
Because it's also a very flexible way of controlling
it. Is. And hooks are kind of a nice way to write this in integration tests, or like not, I will not call them integration tests because it's not the right place, but you can write some kind of end-to-end test or something like that you can verify if everything is kind of okay before allowing the traffic. Enough, like I think it's very, very powerful what you can do with that. So I love the service code deploy.
Yeah, me too. I really, this is one of the best servers in AWS, not related to to serverless exclusively. Like Lambda, a lot of the services are nice as well, but code deploy is kind of big, and it can be used even for on-premise instances, which I was like, wow, how can it be? Well, it is possible.
It is. I don't know how they do it. I never tried on-prem. So.
Yeah. Well, another thing which is important in Serverless.tf approach is that everything is a Terraform module. So Terraform module can do deployment, can do spinning up or customizing, configuring servers, which is not supported in any other way. For example, right now we are using AppSync. And there is no good solution for AppSync, which we can easily adopt. So what we will do is that we will write our module, which is in the same spirit of all other Terraform AWS modules. And if anyone wants to use AppSync, then he just natively connect it and use it. That's exactly the same pattern as all Terraform users have been following for many years. So everything is decomposable and connected the way you want.
Nice.
And in serverless framework, this is solved using plugins or extensions. So there is no need for that, because your code is one thing and the rest is everything else is Terraform modules. So CI/CD with Serverless.tf is no different than CI/CD with any Terraform projects. That's it.
Good.
That's the end of story. No, really. I mean, in Terraform, you describe what you want. You tell Terraform to run init to download some dependencies. You can run plan to see what's going to be applied. And then you tell Terraform to actually apply these changes. So you run Terraform apply. You can do this locally while you're working on something. You want to see how things are going to be working. Or you can use services like Env0, which is specialized service to run Terraform in pipeline. So they have Terraform configuration pipeline as code as well. So you can define how your pipeline should be executed and put this configuration file inside of your repository, and then using GitOps, it will be executed. So your deployment is already part of Terraform. Then you can use free tool, host it yourself, which is called Atlantis. Or you can use Terraform Cloud, which is a more official service by HashiCorp. So there are a bunch of other options like self-managed Jenkins servers or code build. You can use a large variety of services to do that.
Cool.
So now let's look into how this actually looks in action, right? So Serverless.tf demo is a name of repository. I structure it in a way that I have a function which is inside of SRC, and I put only one function here, but obviously this can be any functions structured anyhow with any dependencies you want, and it can be in independent repository as well. For this example, I just put it into this one.
So that's our code.
Sorry?
That's only the code.
Yeah, only the code is here. So this is
the Lambda handler.
Yeah, and Lambda handler is a function name. So the rest of Serverless.tf, and actually the most Serverless.tf related code, is inside a folder called Terraform. If we look into these files, we can see that there are bunch of different files. As you may know, in Terraform, it does not matter how you call files as long as they have extension .tf. Terraform will combine them together in runtime, and it will execute them and figure out dependencies by itself. So if we look into...
Assume that we don't know anything about Terraform, like I do. Don't do
Okay.
it.
So Terraform configuration has some important blocks, for example, provider, where we specify how to connect to AWS. We specify in which region we want to create this infrastructure. And right now, it is using my environment variable, which contains access and secret keys. So that's why I am not hard coding them here. And in general, it's a good idea to put them in environment variables.
Exactly.
And this is one block which contains configuration. Below, you can see the commented block for the situation where you want to use custom endpoints. So if you would run local stack on your local machine, you have to uncomment this one and comment out, well, and you have to comment out previous block. And there you can specify when Terraform will try to reach to these endpoints, it actually has to go to localhost 4566 and use it. So this is the only change which has to be done if you want to make usage of local stack for serverless deployments.
Nice.
So this is one file. Another file which is important, or which it contains a lot of configuration, is actually code for the Lambda module, where we have block module and we have name Lambda. What it means is that
for each Lambda function, I will need to have one of these.
Yes. So what this block means is that Terraform will have to download this source code for this module from Terraform registry. And it will pass all of these arguments like function name, description, and so on into that module. As you can see, this looks very similar to serverless YAML configuration, where you specified just key values for your function. Here you can also specify source path. It can be string, list, or maps of strings if you want to do really advanced configuration with different building options and packaging options. And you also specify that you want to attach several IAM policies, and you want to be able to enable X-ray. So well, this is quite obvious that once you set this option, then this function will have IAM role where X-ray permissions are attached.
Okay, so it comes out of the box. You don't need to write it.
Yeah, there are many different options which can be added. For example, you can add policy statements, because my application or my Lambda function has to read from S3 from this bucket. So this is syntax is how we reference in Terraform that this is IRN of the bucket /star. So which means that this Lambda function will have its own policy attached to IAM role, which is used for this Lambda function. And it's always individual Lambda function. No, Lambda IAM role is only used by one function.
Yeah, like in SUM, for example.
Yeah.
Per function. And then you have a file called S3 bucket or something like that.
Yeah, and this module S3 bucket is actually a reference to this file S3 bucket.
Yeah.
Again, you can put it all into one file if you want. And it depends on your preference, actually. Some people like to put all of configuration in one folder, and this has some drawbacks. Some people like to use different orchestration tools like TerraGrant to have very small, very easy to work with configurations like we do in our company. And this block looks similar. Here we just call in another module, and we are passing different parameters to
One
it.
question. For example, when you don't define in CloudFormation a name for the S3 bucket, it will pick one random for you. How I see there random pet. So is that how Terraform solves that?
Random pet is just name of resource which I use instead of hard coding something. So random pet is also defined here. It is a resource of specific length, and it is just a random string of
exactly. So you have to write it yourself then.
Yeah, all of configuration which you are specifying will be in use. If you don't want to use random, you can put something like.
No, but it's good that it's random, because that's the kind of way to make sure that nobody has the same name. So having a
exactly.
name, it can be very dangerous.
Yeah, and I like to use random pets instead of random UUID because pets are better than UUID. So this is how bucket is created. If we go back to Lambda function, what else we can specify here? So we specify something for the function or for the layer. We specify some. Sorry?
What is that keyword publish?
Publish is just one of arguments which this module accept, and inside of this Lambda module, it will mean that new version will be published.
Okay.
This automatically increased version of Lambda function, but it doesn't do anything with an alias itself.
Okay.
So the next thing is that Lambda function itself has concept of who can execute this Lambda function. And here we need to specify that API gateway, which is created in another file somewhere, has to have permission to call this function.
Yeah. So that is defined in the same Lambda file, or is it in the API gateway file?
This is an API gateway file.
Okay.
The structure is similar. That API gateway of type HTTP is going to be created, and integration with Lambda function for GET request is happening. That this Lambda function IRN is going to be used here. So as you can see, there is no need to hard code anything. Terraform, as I said earlier, is good in figuring out dependencies. So Terraform will understand that Lambda function has to be created first before it can be referenced inside of integrations of API gateway, and so on. So Terraform does it really good in all cases. So the next resource, which is created here, is alias. Alias is like hard link to automatically increased version of Lambda function. Since we specify publish equal true, which means that every time when we change source code, version will be automatically increased. But we may want to have alias which is called prod, which we actually control, and we increase it ourselves using our own code deploy mechanism.
Okay.
So initially, what we have to do is that we have to point alias for this function should be pointing to the current version of the function. This is because alias cannot point to $latest, which is special. So that's why we need to put this. This is only initially. Then we will increase it automatically using code deploy. So this is pretty much it when it comes to all of configuration. So we have
and then if we would like to write other resources like a Dynamo table, we just create a folder and we use the Dynamo modules and we put all the things that it's requesting, and then we give permissions to Lambda to use Dynamo, and that's kind of it.
Yeah, so if you need to call anything like DynamoDB, we have already a module for that where we specify DynamoDB table and then AWS, and then we need to figure out what kind of arguments.
Exactly.
So this is This is a standard way of using Terraform modules.
Nice.
And these modules can be absolutely anything. It can be published on GitHub, or it can be local to this project, so you can point to them as a reference locally, somehow, somewhere. Or it can be your private GitHub registry or any other place. A lot of other possibilities to embed your piece of code, which other developers, let's say in-house, has developed. So let me show how this is actually working.
Yes.
I'm gonna to be inside of Terraform folder where all Terraform code is. And the first command which I have to run is that I run Terraform init. And Terraform init will download, if I scroll back, it will download, well, it will not download because it has been already downloaded. But if I just remove this, just to show that what it's actually doing, is that it's downloading code for each of this module locally. So that inside of Terraform folder, I can actually see source code for all of modules which I'm referencing in this folder. So
nice.
It's downloading everything, it's placing them inside of each folder, and I can see them here. So once this is done, then it also downloads provider required to work with it. So it will understand that it has to use AWS provider because there are resources on AWS and some other providers which are used.
Random for that keyword, like string generation.
Yeah, exactly. So all of this is downloaded once. And the next command here, which we have to do, is that we can see how it's going to be created. You can run plan, and you will see pretty much the same output as if you would run apply. Because if you run Terraform apply, it first runs Terraform plan, and then it asks for the confirmation.
Okay. So basically with plan, you can see what are the changes that are going to happen.
Yeah, you can see this with apply too. Let me...
Yeah, exactly.
Like so it's a little bit too much to see, but the point here is that it's telling what kind of resources are going to be created. All of these modules are creating not one resource like API gateway, but they're all creating a lot of small resources like API gateway plus integration plus another integration plus route and so on, stages and many different resources. When we work with Terraform, we usually see this code and we understand what's going to happen, and we can decide whether this is what we want or not. So we create a lot of resources for X-ray policy because that's what we want. And again, we can see what exactly X-ray policies are going to be created. Because if this is something wrong, then we can easily say that, oh, no, that's not what I want. As well as Lambda function permission, and archive itself. So this is where the building of deployment package is actually happening. So it's going to do zip on this source file, and it will be placed in this file name
folder. Yeah.
So again, I can see everything what's going to be executed, and if I suddenly do something what is wrong, I can prevent it. Normally,
but good luck reading all that long file.
So here we just say that yes, that's what we want, and it takes a little bit time.
Yeah, because now it's going to the cloud and doing all the stuff.
Yeah, and Terraform understand that there are so many dependencies on this Lambda function, so it will first create this zip archive, and then it will create the remaining resources. Right now, there are no long or time-consuming resources, so it has already finished. Sometimes there can be time-consuming resources like
Elasticsearch,
ACM, Elasticsearch or ACM, because it has to create a certificate and validate. and so on. So
nice.
now all of this is done, and we can see
and
that
those outputs are defined by the modules themselves, that they define what are the outputs of that you want. Or
yeah, these outputs come from modules only if they were specified inside of this output block.
Okay, so you have to define what you want to see in the outputs.
Yeah, you can specify, let's say, module outputs, a lot of different things, but you only care about some of them.
Yeah.
So then you can remove large part of it and just leave what you want. So here I have almost all of them.
Yeah.
Most of this doesn't make any sense for me now, but well, they
that's
are,
what I was asking, because at the end of the day, you might only care about the endpoint, for example, to try it.
Yeah, exactly. So I have no clue where is endpoint here.
It was there. It was blue.
Right. Yeah, right. This one.
Yeah.
Point. Right. So if we go to this endpoint, well, it's hard to believe, but I see a valid output, which is hello from Serverless.tf. This is what I see. Yeah, you can just believe. Okay?
Or try it, because I think all of this is available in some GitHub repo, and also in the Serverless.tf they can download these things. So.
Yes. So this is like a straightforward approach where we just specified what we want, and we use Terraform once, and we release it. That's it. That's pretty boring. Now, if we want to change this code,
and if you put in your repository, you need to write, besides your code, you put all these Terra.tf files basically in your code repository, and then that's it. The rest can be generated. The .terraform folder, you don't need to upload it to your, for example, GitHub.
Yeah, exactly. So .terraform should be ignored.
Exactly. But then the rest you put in GitHub, and you can replicate the environment, basically.
Yeah, exactly. So what you can do now is that if you go to your function and you do some changes, quite obviously, if you have this change here, maybe I can even go there and try to run this command. And if I put correct ID, well, which is M6, this one. If I put this number here, now I see the answer is 2.
Yeah.
Serverless.tf 2. That's exactly what we have here. So now if I want to deploy new change, it will be, let's say, new source code. So
that same infrastructure, basically.
Yeah, let Terraform decide what means, what has to be changed.
So Terraform will decide.
You always run only one command. Once you change configuration, you run Terraform apply. It calculates all these 24 dependencies, and it tells that, hey, 3 has to be added, and I can go through them and see what exactly these 3 means. So the first one is that Lambda function itself will have to be updated in place because new file name has changed. Well, that's a good idea to.
Yeah.
Also, version will be increased because it was published. And then it says that Lambda permission will have to be updated. Good.
And version.
And new archive will have to be created. So that's exactly what I expected, right? I build a new one, and I change this one. If I go immediately to the next one, I can see that it's already starting replying as 3.
That was fast.
Yeah, this was faster than I can imagine. Let's make it slow. Let's make it slow. Okay, so this was an easy example, and this worked just as a simple deployment. Now, if we look into this with a code deploy, and let's say we already have some interesting usage. So what I have to do is that I have file deploy tf where I am invoking submodule of Lambda module, which is this 2 slashes means. So it's submodule inside of Lambda module, which is called. And inside of that module, I'm specifying that it's going to use alias, which is called prod. And for this function, I want to go to this version. Well, that's pretty much what I want to do, right? So I want to go to this latest version for my alias. And if I go to below, here is it. I can specify also deployment config name and specify that I want to use Lambda canary. And we can wait for 5 minutes and see something changed.
Yeah.
So we can customize whether we want to wait at all. We can say that in this script or for this environment, I don't care when it's finishing. I don't want to sit and wait. So then I can specify that wait deployment completion equal false, and then it will return. It will exit from Terraform execution immediately.
Oh.
Right now, let's wait for this because it will take like 10 seconds. So it should be fast.
It should be fine, yeah. And there you can also define your alarms and your hooks.
Yeah, you can specify a few things here as well. Or everything what is supported by Terraform AWS provider, actually.
Nice.
Everything related to hooks, CloudWatch alarms, and SNS notifications and triggers notifications. So what we have to do now is that we have to run init again because new module has to be downloaded. So it's downloading this deploy module. Now my IntelliJ suddenly figure out that, hey, it's not orange anymore because it knows it. And now my IntelliJ will actually complete it. So I can say, oh, alarm enabled equal true.
Okay.
It's quite easy to work with it once you initialize this module, and you can figure out all kind of options you want to specify. Let's leave it like this. So now what we have to do is that we haven't changed code at all. But we still need to run apply because we need to create deployment group and and some other resources. So Terraform apply is going to do that for us. It's working quite fast today, which means that there is no demo effect.
Yeah, people are on holidays already.
Yeah. Well, what we have here, just briefly in this view, the biggest configuration is deployment group, where we specify all kind of auto rollback configuration and how to do this, how long to wait, and this is with traffic control, and then of course IAM role for code deployment.
For allowing that.
And we also generate AppSpec YAML file for that.
Yeah.
Because AppSpec file is needed to do deployment, and this AppSpec file actually generated automatically by this module and then passed as an argument. So that's what we want, and we say yes here. And now let's wait a little bit. While it's executing, I just want to highlight that if 10 seconds is long time for you, you can execute it inside of AWS infrastructure, then it will be even faster.
Yeah, sure.
So what's happening now? First, it created all of these resources like code deploy group, and then it's executing shell script, which is actually doing or calling AWS deploy, create deployment for this application, for this deployment group, and so on. And revision is specified in line here. So all of AppSpec YAML file is encoded here. And the next thing which is happening here is that it's actually waiting, because I specified that I want to wait deployment completion equal true. That's why it was waiting for 10 seconds. Yeah.
Yeah, if not, then Terraform will end. If you say you don't want to wait, then Terraform will end and code deploy will do its thing.
Yeah, and code deploy will keep executing whatever
Exactly.
was requested. This is helpful if you have something like this. Lambda
Yeah,
can.
because sometimes it can take like 1 hour to deploy it, and you don't want to have like.
Yeah, exactly. So that's why this is controlled separately.
Yeah.
Then once deployment succeeded, we see the output here as JSON. And yeah, it took 11 seconds overall.
Nice.
That's it. So as a confirmation that this has happened, we can only go to AWS console, and we can see that now prod alias is actually pointing to the latest version. This is exactly what has happened during this deployment. If we rerun this deployment one more time, nothing will happen because code has not changed. Infrastructure is exactly as we described. We can force it if we want by force deploy equal true, but that's not necessary.
Yeah, that's pretty cool.
So you make change here and you keep rolling for your development environment as you want, but your staging or production environment is much more granular, much more controllable. So you use this submodule and you deploy using your own config name. So that's pretty much it.
Wow, that was pretty cool, and I hope I can get all the links from you so I can share them and people can try out everything that you have shared. But one last question: what is the future of this tool? What are you working next, and how you see it evolving?
Yeah, that's pretty tricky question, because on one side I want to continue building this tool, but on the other side I want to earn money to actually develop something using this tool. Well, of course I can go in more detail and explain what exactly I'm working on, but this product started as a need inside of our company. So we wanted to solve this problem for us, and we will definitely continue developing it as we are progressing. So right now we have some need to have upsync resources and resolvers. So we will keep working on that one, as well as step functions. Lots of people have been asking why there is no support for step function. And the main answer for me is that we, as BetaJob, don't use step function.
Exactly.
So that's why we didn't develop it. We only develop features and services which we use 100%.
Yeah, definitely. And that's the thing with open source, that like it's your time and you need to earn money to eat. So your consultancy or whatever you're doing to get your bills paid are sometimes taking over this. But I think if other people want to collaborate, it's an open source project, so maybe they can create modules and and do the work for you.
Yeah, I think
for the community, I would say.
Yeah, creation modules is one thing, but also what is really important is I want to hear from people who can tell me like, hey, this is absolutely wrong, or hey, this is absolutely good. Because right now, I know that there are 3 people who are using all of this, like my company and 2 other companies.
Okay.
That's a little bit too little. So please go to Serverless.tf, as well as a few other projects which I will mention, and tell me that, yes, this is good, or maybe to improve this. So give some feedback.
Let's hope this video raise a little bit of awareness to some people and you get some comments back.
Yeah, I hope so too.
Yes, but I think all the links I will put in the description box of the video, so you can give any projects you want to share with the world and repos or whatever, and they will be all available there, so people can go and check them out. But I think this was quite a long interview packed with information. So I think after this hour and a half, I think people will be Terraform experts. Because at least myself, I feel now that I understand this thing. I'm 2 hours ago when we started discussing about this, I knew nothing about Terraform, but now I feel like, maybe if I sit for a while, I can make my first application with this.
It's quite easy to
try it.
start. It's like with serverless. It's easy to get started.
Yeah.
But when you actually use it for real inside of production, then things are quite different from what we talked about.
That's life.
Yeah.
Exactly. But I think this was the whole interview. So thank you very much, Anton, for spending your time with me today. And I hope you get a lot of questions and comments from people that watch this video asking you about these tools and feedback and all that.
Yeah, I'm ready to answer questions usually.
Cool. Yes. Thank you. Have a great day.
Thank you very much. Have a good one too.
This was the video for today. I hope you like it. If you did, give a big thumbs up. And remember, the thumbs up always help me out to make my channel grow. In the comments, let me know who you would like to interview next or what topics should I cover so I can make content you want to watch. And again, I see you in the next episode of FooBar. Ciao, ciao!